Well, welcome. I hope y'all have had a good week. And as we get here into this next section, section 1.5, here, chapter 1, as I say, I'm going to make each section in general a separate recording. So that way, then you'll hopefully have smaller files. As I say, we discovered last week how that Mozilla would let you download, but Chrome, some of the others wouldn't. So hopefully, by breaking each lecture into smaller sections, things like that, then you'll be able to download them easier. And so we've got here for this week sections 1.5 and 1.6. And so I posted out there my text part of these lectures here for Greek 2. And also, as we get towards the end here, after 1.6, it finishes as chapter 1 on the basics. Then we'll also talk about, and I'll put a separate sheet out explaining, I want you to do a few of the exercises here at the end of the chapter, but that'll be a separate sheet and all that here from the lecture and word and right up here on 1.5 and 1.6. But 1.5 talks about basic structuring of memory and array. And it starts off talking about addressable words. How that each word is referenced by a variable location, and the compiler resolves those memory addresses. So generally, like with any other high-level language, you don't have to worry about the actual physical address out in memory. The compiler takes care of resolving all of those things for you and that type of deal. Now, you can have what's known as direct addressing and indirect, but of course, we're talking about words. And remember, as I talked about, last week, there, when used to think of words, I thought about groups of 4 bytes, 4 characters on IBM 370 assembler. Now, I don't know for any of y'all what other classes you've taken, will take, but certainly try and take an assembler language course. It certainly opens your eyes in a lot of cases to how the machine works, even if it's a different form of assembler than what you're working on. That's okay. The ideas still go ahead of you knowing, just like the 242 architecture course type of deal. But remember, a variable points directly to a memory location holding the data. Whereas with indirect, the variable holds the address of the location that holds the address. So it's like a double point as such. As I say, in 360, 370, we could set a reference location to 0 and then work from that address and counting memory. Even though we don't know the exact address, there used to be a command called branch and link register type of deal, or we could set that value to 0, even though we really knew it wasn't a true 0, but we could work off of it. But as it's kind of talking here a little bit on 33 about, well, do we point directly to the address or do we point to a address that then points us back to where really the data is stored at? And references and all that are very important. We'll talk about parameters in a minute. But Java has the reserved word null, where that you can have absence of references for a variable, you can test for it type of deal. So be aware of those things. Null is certainly very useful to see if there's something in there. So it shows like, well, you've assigned the value of null initially to a variable called circle A. And then if you have the definition of circle B, where circle B equals new circle of size diameter 8, then of course it would point to it with a value of 8. So there's a little bit in here about primitive versus non-primitive types, references. Remember, primitive types of variables are mainly integers, characters, where it uses a value. Non-primitive types, such as arrays and classes, are by reference to the value of the variable. So just kind of be aware of those. Int can be changed. So if you have two locations both defined as integer, if you assign B to A, then they both have the value of B. A gets changed. If on the other hand you have two non-primitive types, an array or classes, and you have, like there it talks about circle, where circle 1 points to one place and circle 2 points to another, and then you say circle 2 is assigned equals C1 equals C2, then they both point to the location of the circle defined by C2. So you can cover those things. One thing that I find very nice about Java is there on the very bottom of page 36 where it talks about garbage collection. And certainly as you're working along, particularly with larger programs, you wind up with memory locations that you don't need anymore. Maybe objects are unreachable at runtime. Say the Java compiler is working in the background, collecting and deallocating those storage locations, freeing them up for other objects and all those things. It's called dynamic memory management. And as we'll talk about there in the next section, 1.6, they're talking about, well, how do we look at how efficient an algorithm is? Well, do we look at execution time or otherwise? Well, what if while you're making that assumption on how efficient that algorithm is, the compiler is doing garbage collection in the background? Well, that's stealing machine cycles. And so hopefully y'all are also familiar a little bit with machine cycles, time sharing, things like that on how the CPU allocates between. There's, some of y'all are familiar with virtual memory or pagination or segmentation. And so, there's, as I say with assembler, there's so many things that now on a PC that we are so used to talking about. Terminology, virtual memory, pagination, segmentation, spooling, things like that used to be mainframe terms. But remember, when you load your program, and I don't care whether it's a Java program or it's part of Office, your computer loads as much of that program into available memory as possible. Then, as you're working your way through with virtual memory or pagination or segmentation, unused parts of the program are sent out to the hard drive as the operating system brings into you parts of the program that you're trying to execute at that point. So like if you in Word aren't using the mailing section, well, maybe the compiler or the operating system, I should say, in the background sends the mailing portion out to the hard drive, stores it that way, while maybe you're working with bringing a graph in or whatever. But if on the other hand you bring the mailing section in, then parts maybe of the program you're working with, reference or whatever you're not using, gets sent back out to main memory, out to the main hard drive. And you don't see as much on Windows 10 as you did with some of the earlier operating systems, XP, where it would come up with a virtual memory and then would say, do you want Windows to manage your virtual memory? And you would say yes. And all that's going on in the background, but it takes time. So you can have where you can compare objects with primitive variables are equal if they're the same value. And remember in Java you have equal equal, and that is the logical equal sign. And or you have non-primitive, they're equal only if they're aliases for each other. You can go through, and it talks a little bit about here about passing parameters either by value or by reference. And as I say, if it's by value, then you do it directly. If it's by reference, a copy of the arguments are passed. So in Java, all arguments are passed by value, or if they're primitive, they're passed by value type of deal. Address of the object if it's reference. So then we get over here to arrays. And arrays are true for most any language or even package. Whether it's a third generation language like Fortran, Basic, COBOL, PL1, whatever. When I've taught the CSC 490 statistical analysis using the statistical package SAS, SAS has the ability to define an array in its procedures. So arrays are very, very much used throughout as just a way of accessing sequential data locations of the same type of data. They're non-primitive, just like objects. Now, an array must be instantiated, instantiated, which means you must state when you define or instantiation of the array how many elements. So like if you have the command numbers equal new int bracket 10 bracket semicolon, then you have an array of 10 locations, all integer, referenced by numbers, sub, whatever. So if they're primitive types and they're set to a default value, if they're a reference type, they're an array or classes, they're set to null. Now, one thing that you have to do, remember, or keep up with an array is you have your index. And that initial location, remember, on an array is sub-0. A lot of other locations start with 1. So if you move from one language to another, that's one of the rules that you have to remember is Java, you start with an index of 0. So if you have 10 locations, you go from sub-0 to sub-9 as your subscript. And you can also, as it points out, you can create initial values. So it's got a thing here like int number. So it's declaring the array numbers of type integer. And then it says equals 5, comma 32, comma minus 23, comma 57, comma 1, comma 0, comma 27, comma 13, comma 32, comma 32. Close parentheses, semicolon. So you can initialize an array with values. One thing that I am very impressed with here with Java is how it handles a subscript out of range error or index. A lot of languages, if you have 10 positions in the array and you try and access the 11th position, well, you don't know what might be in that memory location. You will hopefully cause a abend of your program where it will drop on you. And then otherwise, you don't know. Excuse me. So like some languages like C++ don't check. But if you try in this case where you have 10 locations, 10 elements, and you try and reference something less than 0 or greater than 9, then Java is going to throw an array index out of bounds exception, and then you would handle it however you wanted to handle it. So it's good that you have it. So each array is a public instance variable of type int called length. So if you're unsure about how big an array is, the number of cells, then you can say numbers.length would give you a value of 10 since our array numbers is defined as 10 positions going from 0 through 9. So you can have arrays of objects. It talks about circle, bracket, bracket of all circles equals new circle 10. Remember, in this case, since we have an object, then it sets the value of all those to null. But you can generate images, and it goes through, it has this rather extensive code there on pages 40 and 41 to generate those JPEG images. But it uses that package ch01.apps. And that package available from the publisher, supposedly, on pages 21 and 22. Well, when I go out and type in that address there on 21 and 22, I get an invalid link to download the library file for all of these chapters. Remember, you'll use these library files both here for the first half of the course, 345, and the back half, 346. And so I'm going to be contacting the publisher first thing this week and about getting a valid link, and I'll be link to the programs and data here for the book, and I will be letting y'all know. So the last thing really kind of the chapter talks about is two-dimensional arrays. And you certainly see most languages have a way of handling two-dimensional arrays. Now, it's always important to know on a two-dimensional arrays, how does it reference it? Does it reference by row first and then column? Some languages, you define the column and then the row position within the column. So when you declare an array, you just say double, like bracket, bracket, alpha. And then it says alpha equals new of double precision, like 100 in brackets and 9. So then it would set up a two-dimensional array with 99 rows, and within each row 10 columns. And remember, your upper left-hand most position is 0, 0, going all the way through 99, 9. So you just got to remember that here with Java as you go from 0 to whatever, n minus 1, I guess. But the columns, of number of columns in a row, you can specify by saying the length of a given variable, type of deal. So you can work your way through there. So like row length equals alpha of going to row 30. And then it'll tell you how many columns. And as I say, a lot of languages support multi-dimensional array. Java doesn't really. A two-dimensional array in Java is an array of reference to array objects. So if you had a three-dimensional array, it'd be created as a two-dimensional array whose elements are arrays. So forgive me for yawning on you. So that's everything here on 1.5. And so then we'll get here in a minute in 1.6, and we'll make it a separate lecture type deal. But as I say, I'm always available for y'all with us moving back on campus this week, since it's the week of the 23rd. I do want to set up either Monday night or Thursday night with an on-campus office hour as well as virtual. I'll set up a Zoom. Y'all just need to let me know which y'all want me to be available to y'all in person at, either Monday night or Thursday night there on campus, or as well as virtually, to answer questions, things like that. And so let me know that. But keep me posted, contact me, call me. You got my numbers, email me. So I'm fixing to save this lecture here. It's about 20 minutes. So hopefully it will save out there and be openable by being much smaller by other types of web browsers other than Mozilla. So enjoy this one. Keep reading the notes, and I will make 1.6 in a minute.